5.2 Characteristics of polynomial functions. Here we have the function f of x is equal to 2x cubed plus 4x squared minus 3x plus 1. The first thing that we're trying to determine is the degree of our function. So we have to look at our variables. We're looking for the variable with the highest power. The variable with the highest power here is x to the power of 3. So the degree is going to be that highest power, or the highest exponent, 3. Now we could also tell by looking at the graph, this is clearly a cubic function. Okay, and cubic functions always have a degree of 3. The number of x-intercepts, as we can see, this graph crosses the x-axis one time. But this is not true for all cubic functions. Some cubic functions could extend downwards like this, or it could extend and just touch the graph and move back upwards. So we can have 1, 2, or 3 x-intercepts, but for this specific function, we have just 1 x-intercept. Now, as previously stated, our y-intercept is always equal to our constant term. So we can see here that the graph is crossing the y-axis at y equals 1. And this is true for all polynomial functions. So our y-intercept is 0, 1, with the y value always being equal to that constant term. The end behavior here, well, the function is starting in quadrant 3, and it's extending into quadrant 1. And you'll notice that this is very similar behavior to a positive linear function. So positive cubic functions start in quadrant 3 and move into quadrant 1, as well as positive linear functions also start in quadrant 3 and extend into quadrant 1. The domain for our function, well, we have to look at our x values. Okay, I'm seeing that my graph is extending slowly outwards to the left, and it's also extending slowly outwards to the right, which means that my x is going to continue getting smaller as we move to the left and bigger as we move to the right, which means that I can have any x value. X is an element of the real number system. Okay, any x value, any real number of x can be applied to our function. Now let's look at our range. Okay, let's look back at our graph. We can see that our graph is extending upwards, and it's also extending downwards. As it extends upwards, our y values are going to continue getting bigger and bigger. And as it extends downwards, our y values are going to continue getting smaller and smaller, which means that my y can be any real number. Y is an element of the real numbers. And then now we have to look at our turning points. Okay, we can see that the graph is moving upwards. Okay, there's a turning point, it starts moving downwards. There's a second turning point, and then it starts moving upwards again. So we would have 2 turning points in this cubic function.